Hey there, welcome back to another video with the Math Doc. We're continuing on our path with multi-step equations, and today we will focus on equations that have variables on both sides. What does that mean? It means that we have an equation, right? We have something on the left and something on the right, and on both sides we have some terms that include our variable x. And we will work in this video on just solving a couple of examples. Next video, we will look into some word problems that involve equations with variables on both sides. But basically, we will take the same steps we have until now. We will move terms around by using our various properties. As always, we will look for the inverse operations and then use those properties to group together like terms. We will group together the variable terms, terms with x's on the one hand, and then on the other side we will try to group together constant terms. So we have variable terms, and these involve our variable x or any other letter we use, and then we will also have constant terms, and constant terms involve numbers, 7, 31, 42, whatever they are, but they do not involve the variable. So our goal, as always, will be to isolate the variables so we can get the result. But we will have to take sometimes a few more steps when we have the variable on both sides. Of course, at the end, we should always check our result by substituting in the original equation. And if it's a word problem, we should also always make sure that the result makes sense in terms of the word problem. So let's just get started with our first example, which is 3 times x plus 2 equals x minus 1. So here we do have our variable on both sides of this equation. So our first step will be to try to move the variable to one side only. Let's try to group the variable terms on the left. Okay, how do we do that? Well, on the right we have x. It's actually plus x, right? We're adding it to the equation. And so let's use the inverse operation. The inverse of plus x is minus x. So we will use the minus x, which will mean we'll use the subtraction property of the equality in order to group the variable terms. So let's subtract x from both sides. So on the left-hand side, we have 3 times x plus 2 minus x equals x minus 1 minus x. And now we can use the commutative property in order to move some terms around. These are all addition and subtraction, so they are equal in their order of operation, and I can move them around. So I'll write this as 3 times x minus x plus 2. So I switched between these two. And here I'll write x minus 1. So again, I switch between these two. Now, x is a variable. We don't know what x is. However, we do know that x is the same. This x is the same as this x, is the same as this x, is the same as this x. It may be the number of children in a classroom, it may be the amount of dollars in your account, but regardless of what it is the same x. So on the left here, I have 3x, but then I subtracted one of my x's. So I had 3 of them, and now I only have 2. So that is 2 times x. And let's bring down our 2 here as it is. On the right-hand side, we had 1x, but then we subtracted the second one, right? That's subtraction. So we have no x's. We have 0 times x. And let's bring down the negative 1 here. Okay, so let's write this a little more neatly. We have 2x, 2 times x, plus 2 equals, since we have 0 x's, we don't have to write it. We have, on the right-hand side, we just have negative 1. Now our next step will be to try to group or combine the constant terms, right? Because they are also on both sides of the equality. So in order to do that, we would like to move this plus 2 here. The inverse operation to plus 2 is minus 2, right? So let's subtract 2 from both sides. So we have 2 times x plus 2 minus 2, so that's plus 0. They cancel. And minus 1, or negative 1, minus 2 is just negative 3. Okay, so now we really do have the variables on one side and the constants on the other. However, we still have this coefficient 2. So we have 2 times x. What is the inverse operation to 2 times? It is divide by 2, right? So we will divide both sides by 2 using the division property of equalities. So we divide by 2 both sides using the fraction symbol. Now on the left we have 2 times x, divide by 2, and since it's the same 2, we can cancel them. It's like saying we have 2 halves, which is just a whole, equals minus 3 halves. So that is our result, and we can check the result, right? We check by substitution. So our original equation was 3x plus 2 equals x minus 1. Let's write that out. 3x plus 2 equals x minus 1. Okay. Now let's substitute x equals minus 3 half. That was our result right here. Okay, that's why we're substituting that number. Okay, let's write it out. 3 times, and instead of x, I'm going to write minus 3 halves plus 2 equals minus 3 halves, or negative 3 halves, minus 1. Okay, what do we have on the left? We have 3 times negative 3 halves. That's negative 9 halves. Let's write out 2 as an improper fraction. We'll write it out as 4 halves, right? 2 is equal to 4 halves. On the right hand side, we have negative 3 halves minus 1, which is exactly minus 5 halves, right? Because the minus 1 is minus 2 halves. So I did that in one step. Now we can write a common denominator for this left-hand side. We have negative 9 plus 4 equals minus 5 halves. And we're still wondering if this is correct. We're checking. Now negative 9 plus 4 is just negative 5 halves, and that equals 5 halves. So indeed, we solved our problem correctly. So we went through all the steps, and we checked our result. Let's look at a second problem, a second example, and this will be the final example for this video. Our second example will be slightly more complicated. It's 4 times, and we have a parentheses, x minus 7 equals 3 times x plus 2. So again, we have our variable x on both sides of the equality. And this time, we also have parentheses, so we have to be careful with our order of operation. So usually what I like to do in this type of problem is, first of all, open the parentheses using the distributive property. I'll remind you, not party, but property. I'll remind you what that is. If we have a formula a times b plus c, that equals a times b plus a times c. So we can open the parentheses, but we have to multiply each one of these elements by a, and we have to make sure that we include that plus sign here. And the same happens for a minus. So if we had a minus b minus c, we would have the same thing, except we would have a times b minus a times c. Okay, so let's apply that to this equation. We have 4 times x minus, because of this minus here, 4 times 7 equals 3 times x plus 2, where we haven't done anything with our right-hand side yet. Let's write this out a little more neatly. We have 4 times x. We can remove the parentheses because it's just one element there. Minus 28, 4 times 7 is 28, equals 3 times x plus 2. Okay, now we'd like to group together all the variable terms. So let's use the inverse operation to plus 3x, inverse operation to plus 3x is minus 3x. So we will subtract 3x from both sides. So we're using the subtraction property of equalities. We have 4 times x minus 3 times x minus 28 equals 3 times x minus 3 times x plus 2. Remember, it's the same x, and so if I had 4 of them, and now I took away 3 of them, I'm left with just one x on this side, and I won't even write the 1. X minus 28 equals, I had 3x, I took away 3x, so I'm left with no x's. I have 2 here. Now I'm going to use the inverse operation to negative 28, which is just plus 28. So I'll add 28 to both sides in order to isolate x plus 28. So I get x minus 28 plus 28 equals 2 plus 28. And again, the 28's here cancel because we use the inverse operation, and we get x equals 30. So that is our result. And if we can check again by substituting, what was our original equation here? It was 4 times x minus 7 equals 3x plus 2. Let's write that out. 4 times x minus 7 equals 3 times x plus 2. And we will substitute x equals 30. So we have 4 times 30 minus 7 equals 3 times 30 plus 2. There's a question mark there. 30 minus 7 is 23, so 4 times 23 should be equal to 3 times 30 plus 2. Let's do the multiplication here, right here on the side. 4 times 3 is 12, so we have 2 and we carry 1. 4 times 2 is 8, so that's 92. So we have 92 on this side. And on this side we have 3 times 30, which is just 90, plus 2, which is 92. So yes, we got the correct answer. If this was a word problem, we would try to figure out whether x equals plus 30 makes sense. But this was just a simple example. So thanks again for joining me. If you're new to the channel, please subscribe, like, comment. All your comments are welcome. And in the next video, we will go through a few word problems that specifically focus on equations that have the variable on both sides. So see you next time.